Hello and welcome. My name is Keith Wray. Welcome to Wray in the Bay, Vehicle Steering Systems, keeping it between the ditches. My first experience with any steering system was exciting to say the least. At about 10 years of age, when many older kids were loading up to go to Woodstock or Glastonbury in the UK, my little brother and I were scheming about how we could build a go-kart. We had scavenged 4 mismatched push lawnmower wheels from a neighboring farm's junk pile, with permission, of course. Our mother would claim that we moved that junk pile to our yard over the years. We also found some old rusty rebar, and that could work for some axles. Dad let us have some old 2x4 from the shed, and we were busy pulling 16-penny nails out of old lumber in the used wood pile when it dawned on me, how in the world are we going to steer this thing? Well, we were going for the classic T-shaped design. The axles would attach to the bottom of 2 short pieces of 2x4. Then a longer piece attached those 2 short pieces. That's basically the seat. Then you drive with your feet. Our fastener inventory consisted of only the used 16-penny nails, so how would we fasten a steering axle to the main frame and be able to steer? A 16-penny nail wasn't long enough. So we shared this dilemma with Dad, and he thought a minute, then stuck his index finger in the air to indicate, stand by. He walked to the shed and grabbed a mason jar filled with assorted nails. He pulled out a 4.5-inch nail. That would make the perfect steering spindle. So we attached the rebar to the 2 2x4s by hammering in nails partway, then bending them around the axles. We had cut the rebar to length with Dad's hacksaw. That took an hour, it felt like. He had lent us his drill to make holes, and we put a bit nail through that hole to hold the wheels on. And we drove that big long nail through to make the steering spindle and then bent it over. That took about another hour, I felt. Then, listen, we added a rope to the steering axle. And thinking about that now, the rope made it power steering. We are ready for a test drive. My first instinct was to put my little brother in the driver's seat and send him down our big hill. On the other hand, anybody that's the oldest sibling knows that they are responsible and accountable for the well-being of all the younger ones. If my brother got killed on this tacked-together race cart, I'd never hear the end of it. So at the top of the hill, I took the driver's seat, if you can call sitting on a 2x4 a seat. I remember thinking my brother might have pushed a little too hard for this trial run. About halfway down the hill, the whole thing was vibrating and jumping around so hard I was glad we had added the rope power steering for me to hang on to. All of a sudden, the rear axle, the rebar, fell off the 2x4. The cart slid sideways. I hit the asphalt/gravel road rolling. I stopped when I hit the ditch. Looking back, my brother was rolling too, laughing. I was bruised a bit, certainly scraped up, as I hollered for him to get more nails to reinforce the axle. We spent a lot of time on our race cart, but it worked, and the steering never failed us. You know, in our industry, there are 5 types of steering systems, and none involve a nail. They are worm and sector, one of the first widely used steering systems utilizing a worm gear that meshes with a sector gear to turn the wheels. That was late 1800s, early 1900s. Ford's Model T and Model A used it. Next was the recirculating ball. It featured a worm gear, rotating ball bearings within a housing to reduce friction and provide smoother steering. That started with a 1940 Cadillac and still used today, actually, but with hydraulic assist. Rack and pinion, a compact, efficient, and simple system that used a shaft, a pinion, a rack, and tie rod to translate rotation into linear motion. It's used often in small cars. The BMW 303 was the first rack and pinion in the 1930s. The first U.S. built was the 1974 Mustang and the Pinto. Hydraulic power steering, a compact system that uses hydraulic power assist to help the driver turn the steering wheel. It's known for its superior steering performance. The concept of assisted steering dates back to the late 1890s, actually. The first commercially available power steering was the 1951 Chrysler Imperial. Electric power steering, EPS, a modern system that uses an electric motor and sensors to assist the driver in turning the steering wheel. It's popular for its fuel efficiency and flexibility. The evolution of steering systems primarily saw the development of mechanical systems like worm and sector, recirculating ball, followed by the introduction of power steering, with hydraulic systems being the first widely adopted. Later, transitioning to this electric power steering as technology advanced. The most common modern system today is the rack and pinion steering, often combined with electric power steering. So we're going to be discussing the electric power assist component. OEMs are moving aggressively to EPS because eliminating an engine-driven hydraulic pump increases gas mileage by about 1 mile per gallon. Advances in electronics led to the development of EPS, which is now widely adopted in modern vehicles for its efficiency and adaptability. The history of electric power steering actually dates back to the late 19th century, with early patents for electrically assisted steering systems existing even before the first automobiles. It gained widespread adoption in recent decades, with the 1990 Honda NSX being one of the first production cars to feature a fully electric power steering system. The key development being the ability to integrate sensors and adjust steering assistance based on vehicle speed and other factors. That made it more efficient and driver-friendly than the older hydraulic systems. In most vehicles, the electric power steering motor is located within the steering column, meaning the EPS is part of the steering column assembly. The design is often referred to as column assist EPS, where the motor is mounted directly on the column itself. Key points about EPS in the steering column. Function. The electric motor within the steering column assists the driver by providing power to turn the wheels, making steering easier, especially at low speeds. Sensors in the steering column detect the driver's steering input and torque, allowing the EPS system to adjust the amount of assistance needed. Space saving. Placing the EPS motor in the steering column is a common space-saving design choice for smaller vehicles to save that space. While doing research on electric power steering, I found a complimentary SureTrack blog. I found some points very interesting, especially this one. So with what we have been talking about, may come down to replacing the entire steering column to properly repair these car steering systems. Let's take a look at it. So here's the blog. I'm going to read straight from the blog to you. So this was on a 2006 Saturn, and it had a code C, chassis code CO475, power steering inoperative. The complaint was the customer states the power steering is inoperative. The customer also states the anti-lock brake system, ABS light, is on. Cause. So this shop confirmed the customer's complaint. They found the power steering was inoperative. They connected a scan tool, found the code CO475, which is electric steering motor circuit. With the engine at idle, they monitored live scanner data while attempting to turn the steering wheel from left to right, and found the electric steering motor parameter was fixed. It was stuck, it didn't move. Performed an inspection of the electric steering motor wiring harness, connector, and they found no faults. So with the ignition on and the engine off, they used a multimeter to check the presence of voltage and ground at the electric steering motor connector, and found both were present. So good power, good ground. So the electric steering motor is found to be faulty. The electric steering motor being integrated in a column, place the steering column. Verified correct operation, customers out the door. So the typical electric steering assembly would consist of steering angle sensors, torque effort sensor, the electric motor itself, and the electric steering rack. Some refer to this as an electronic power system. I certainly wouldn't argue that. What happens if the steering angle sensor is not calibrated with a scan tool? Well, if the sensor is not calibrated properly, the ADAS might misinterpret steering inputs, leading to a false warning or maybe even an inappropriate vehicle response. If it's not calibrated, it would certainly be a comeback. What are the signs of a faulty sensor? Well, a warning light, certainly, and that would be the most noticeable sign. It's usually the electronic stability control ESC or traction control light illuminating on the dashboard. This feel of the steering, you might experience a loose or playful steering wheel, meaning there's a noticeable movement before the car starts to turn. Inconsistent handling, the car might feel unstable or pull to one side during turns, especially after a wheel alignment. Loss of stability control functions, features like traction control and stability control might not work properly due to inaccurate steering angle data. And then squealing tires. In some cases, a faulty sensor can lead to excessive tire wear and squealing noises when cornering. According to available information, several OEMs, original equipment manufacturers, have reported issues with electronic power steering. That includes Toyota, Honda, Ford, GM, Vauxhall, and Nissan. However, it's important to note that EPS problems can occur across a wide range of car brands due to the complex nature of the system and potential component failures. Not every vehicle from these manufacturers will experience issues. I worked in an alignment shop in the late 70s before ending up at that Datsun dealership I've told you about. The alignment machine that I utilized had a tape measure and string with it. That was part of the process. My main steering repair tools were a couple of wrenches, a hammer, a pipe wrench, and a pickle fork. Tools just slightly more advanced than we used on that go-kart. I would not have dreamed in a million years that we would be required to hook a scan tool up before performing an alignment to calibrate, reset, or relearn various electronic components in today's world. I have to say, I have never had to replace a steering column. I think I'm glad about that. So thank you for joining me on another episode of Wray in the Bay.